Hello, everyone. Welcome to Cloud Native Live. We are diving into code behind Cloud Native. I'm Paulo Simões. I'm uh, CNCF ambassador and the developer evangelist from Oracle. And every week we bring a new set of presenters to showcase how to work with Cloud Native technologies. They will be build things, they will break things, I hope so, and they will answer your questions. Join us every Wednesday at 8 a.m., 11 a.m. ET. And this week we have a pleasure to receive our friend Chris Tompkins from Tigera. He'll talk about Calico, talk about eBPF, and how turbocharging AKS network with these both projects, amazing projects. Uh, this I should remember this is an official live stream from CNCF and subject of CNCF code of conduct. Please do not add anything to the chat or questions that would be in violation to that code of conduct. Basically, please be respectful of all of your fellow participants and presenters. With that's all I hand over to my friend Chris to l- show to us, break the code for AKS with ABPF and Calico. Hi, Chris. How are you doing? Nice to
Hi, I'm
meet you.
very good. I'm very good. I'm near to London and it's unbelievably hot here today. So I have a fan on behind me. I hope you can't hear it too loud. But yeah, I'm good. I'm good. So my name's Chris Tompkins. I work for Tigera and Project Calico. I'm a developer advocate. So it's my job to get out in the community and understand community's requirements and help the community to understand our products and our open source tools. So should I start by telling you a bit about Project Calico, just to make sure people know about that?
Yeah, Chris, it's listen a lot about Calico, listen a lot about eBPF, and so it's amazing know about these projects. Please show us a little bit about this.
Great, I
Go
will.
on. Thank you.
So I just want to say, first of all, don't worry, there won't be too many slides. I don't like sitting through too many slides. So we only have, I think, 6 slides in total, including the one you're looking at. So Project Calico is an open source networking and network security solution. It's a way to connect together your containers, your virtual machines, and your host-based workloads. And it implements best practices for kube security with excellent performance, and it is running in over 1 million nodes in the cloud today. So it's battle-tested, production-hardened code with full support for Kubernetes network policy, interoperability with non-Kubernetes workloads, and a really large active contributor community. So it's a really successful project. Why is it showing that on there? That's annoying. Wrong screen. Okay, I'll do it this way. We have a Slack channel, which I think will be mentioned in the chat later on. But if you want to get involved with us, come and talk to us in our Slack channel. We have over 6,000 members, over 150 contributors. But we're not just talking about Calico today. We're talking specifically about the eBPF and how eBPF relates to Calico. Do you want me to talk a little bit about eBPF first?
Oh, yes, please, a little bit.
Great, cool. I wonder if we should jump back just down to the videos, to our video feeds, take away the slides for a bit. But I made some notes to share about what eBPF actually is, first of all. So forgetting about Calico for a moment, if we want to get exceptional networking performance in a Linux node, one way to do that is to implement the code inside the Linux kernel. Because obviously, if you put the code in the kernel, you can get really great performance. but that brings with it challenges. If you want to put code into the kernel, maybe you have to write a kernel module, and you have to get that approved and get your PRs approved, and that can be quite challenging. So the Linux kernel, back in the 90s, it had the Berkeley packet filter, BPF. It's not eBPF, but the original Berkeley packet filter added. And really, it's a way to implement a safe, secure, lightweight virtual machine inside the Linux kernel. And it runs bytecode that can take advantage of a subset of features. So more recently than the original BPF, we got eBPF, which is the extended Berkeley packet filter. That's much more recent, and it's dependent on a Linux 4.x kernel. And it's entirely restricted to Linux for the time being. We'll talk more about that later, I think. So you need a fairly recent kernel, but once you have that, you can run a safe, secure, lightweight virtual machine inside the kernel without changing any kernel source code. So you can have an event-driven program that is compiled to bytecode and then attached to hooks inside the kernel. And when those hooks are called, then the attached eBPF programs are executed. Does that make sense?
Yeah, sure. Let me ask you. Today we will talk about AKS, how you leverage the eBPF over AKS. Uh, no, for us, just AKS has this capability, or
No,
other providers, and
I'm
the
glad.
vanilla Kubernetes has this capability.
Yeah,
How
so
can I adopt this? It's a recommendation.
yeah, I'm really glad you asked that question, because no, it's not just for AKS. We want to, when we do later on in this session, we'll do a demo, and we wanted to focus that demo on a particular platform, so the demo is clear and everything. And there are subtle implementation differences between using Calico eBPF on the different platforms, but you can use it on Azure, you can use it on AKS, EKS, and many other ways. So no, we can use our eBPF data plane in many places. So once you have this code that you can run in the kernel, it obviously makes sense for certain use cases, right? Because there's a limit to what you can achieve, because you are only given certain helper calls by the kernel. So that in order to keep you secure and make sure you don't do anything malicious, the kernel will only allow you to call certain helpers. And those helpers are aimed towards doing networking, doing logging, firewalling, debugging, those kind of things. So this is a perfect fit for Calico, because if we pivot over to talking about Calico rather than eBPF for a second, we're essentially a network network component for your Kubernetes clusters, and like most networking implementations, we're implemented as a control plane and data plane. In the same way that if you go back to a router or a switch, you will have a control plane and a data plane. Calico is built with the same model. In fact, I should mention, I did another talk. We did a Kubernetes Security and Observability Summit. And in that talk, I did a talk called The Importance of Modularity and Data Planes. And if you want to find out more about the data plane support in Calico, that talk would be useful. But for today, what you really need to know is that Calico uses a control plane and a data plane architecture. And we have several options for the data plane. Now, by separating out the control plane and the data plane, it allows us to separate out the functionality of those two roles. So the control plane's job is to manage the high-level view of the network. For example, maybe to run BGP daemons and to run the routing protocols that have the whole holistic view of the network. And the data plane's job is to forward the user traffic and to do so quickly. So the control plane is a complicated bit of software that needs to be complicated, and the data plane should be minimal, fast, lean code. So for that reason, Calico was designed with modularity in mind. From day one, it was designed. I mean, I haven't been with Project Calico since day one, but I've spoken to people who have been, and they knew from day one that they wanted to have this clear separation between the control plane and the data plane components. And because it was designed with a modular separation and a clear interface between the layers, it made it very easy for Calico to implement multiple data planes. So the original data plane that Calico supported was the Linux IP tables data plane. We still support it, and it's quite high performance. It's battle tested. We support a Windows host networking data plane, and we support the Linux eBPF data plane. So that's because we wanted to take the advantages of Linux eBPF and apply them to our product without needing to throw away any of the hard work or implementation work that was done making the control plane stable, reusable, and so on. So we have those three data planes: Linux IP tables, Windows host networking, and Linux eBPF. But I should mention also we have a fourth data plane, which is vector packet processing, which is another data plane which is amazing especially for high encryption performance. So, but we won't talk about those other data planes today. I just wanted you to be aware that they exist and that's the background for why we have this Linux eBPF data plane. Does that make sense?
Yeah, sure. Yes.
Cool. So
thank you for this explanation. It was amazing. Thank you so much. Let's show the code.
Yeah, let's
break the code.
I should have said one more thing though before we do, which is what are the advantages? So the advantages are performance. The Linux eBPF data plane is really fast, and it uses less CPU. But there is also another big advantage, which this is where I'm going to have to use some slides. Now, I promise you I only have 4 slides, so I hope it's okay. I'll jump across to here. So this is the first one. It's the data plane benchmark. Now, this benchmark was not done on AKS. The reason it wasn't done on AKS was because we wanted to test 40 gig networking. So we did it on bare metal servers. But you can see that with a Jumbo Frames MTU, you can see that the throughput is a little bit higher with eBPF. But with a normal internet MTU of 1440, you can see that the performance is dramatically higher, right? So I don't want to do too many slides, so let's move on. I don't want to dwell on that for too long. The other one is this one, and it's just the CPU usage. So you can see that the eBPF, and this slide is specifically for AKS Azure. You can see that the TCP pod to pod and pod to service throughput, CPU utilization doesn't change very much, but you can see that the UDP pod to pod and UDP pod to service is dramatically lower CPU utilization, which is great. So that's it for the benchmark slides. But there is another advantage to this data plane, which is pretty cool, and I'll demo it in a moment. That is that in a Kubernetes cluster, I'm sure you know that these services are usually implemented by kubeproxy. So if you have services in your cluster, it's kubeproxy that implements those. But if you replace kubeproxy with an eBPF data plane, you don't actually need to run kubeproxy anymore. So the service functionality that is offered usually by kubeproxy can be offered instead by the data plane itself. So you get a latency reduction, you get less moving parts, less complexity. And the most interesting one is that you get to preserve the source IP. I'll demonstrate that in a minute. So this is how it looks without eBPF. Your external client comes into a Kubernetes node and they talk to a service. And you can see that the Kubernetes node that is running kubeproxy has to destination NAT and source NAT the traffic. And it does that so that in step 2, it can forward the traffic onto the other node. Then step 3, the pod that is responding, the pod never gets to see the original external client source IP. And then the return traffic has to go back through the other node. So this is a problem if you want to do audit logging. Maybe you want to capture the IP address of all the users, and that happens in the code that runs on the pod. So once you switch to eBPF, then you get this. It's very similar, right? But instead, you can see that where the Kubernetes nodes are, you can see that instead of kubeproxy answering the service, you can see that in step 1, the BPF program answers the service. It does a destination NAT, but not a source NAT. And that means that when the service pod receives, actually, I don't like the terminology service pod here. When the pod, the pod that is serving the content, when that pod sees the traffic, it sees the real source IP of the user. So that's the other benefit. So just to recap, and then that's the end of the slides. But just to recap, the reasons you would want the Linux eBPF data plane, you get great performance, lower CPU utilization, and you get these benefits of being able to see the source IP. So yeah, so let's jump across and I'll do the demo, right?
Right.
Cool.
Very good. Oh, amazing explanation. Thank you so much.
No worries. Oh, how is that? Is that readable, or should I go?
Oh, increase a little bit, please.
Yeah, there's one, potentially one small, oops, hold on.
Oh, small. This is small. Oh,
yeah, let me remember.
Oh,
that's strange. Hold on.
Okay.
Having a little problem with my, oh, there we are. I need to learn to use my computer properly. Okay, that's better, right?
Yeah, it's better. It's better.
We might have a small problem with that because I used. Are you familiar with Askinema?
Oh,
I used this tool called Askinema.
Yes.
Yeah, I used this tool called Askinema to record the demo, so that rather than having to wait while the slow parts run, we get to see it running quicker. But it can be a little bit fiddly with the terminal size. So we'll see how we go.
Let's go. Let's try.
Okay, so I did this demo this morning. So it's not running live now, but it is very recent. So the first thing I'm doing is using the Azure CLI, and I'm turning on this feature flag for the container service namespace called Enable AKS Windows Calico. And this is just a feature flag to tell AKS that we want to use Windows Calico. And I believe it also changes the deployment model. It's just a step that needs to happen for this to work. Now, because I have already done that before, it immediately says state registered. But if you do this on your own cluster, you'll find that it says state pending, and then you can you can run this other command as your feature list, and this will tell us when the command is finished registering. So I do that now. There we go. So you can see this is just me confirming that it's registered. And then the last part is we just need to re-register the features. We need to re-register them with the provider. Okay, so now we can actually start doing the real work of deploying an Azure cluster. So the first thing I do is I use the Azure CLI again, and I create a service principal, which is it's an identity for the service to run as, essentially. So once I've done that, I've stored the service principal in a variable called SP. And the reason I've done that is because the output contains credentials. So I don't want to share those credentials with the internet right now. Oh, I should say as well that these strings up here, I've actually modified them. So these are not the real strings, so that if anyone malicious thinks they can jump in, then these will not work. So we take the output and we grab the service principal ID. And the service principal password. And all we've done really is we've taken those two variables from this variable. So the next part is to actually create a resource group. And the resource group is just somewhere for us to put our resources. So you can see that we created a resource group called Live Demo RG, and we put that in Canada East. Now we get to the interesting stuff. So now we're actually creating the cluster. So AZ AKS create. So we're creating an AKS cluster. And because I was working from some old notes, when I first did this is proof that it's a real demo. When I first did this, you can see that I specified Kubernetes 1.20.2. And you can see that it's saying 1.20.2 is no longer supported. So that's no problem. So I just run AZ AKS get versions. And it returns, you can see it returns the versions that are valid. So instead of the original 1.20.2, I just switched it to 1.20.7. There we go. So it'll take a moment for this command to run. You can see what we're doing is we're specifying that we're creating a cluster. We want to put it in this resource group. We give the cluster a name. We say we want 2 nodes in the cluster. We specify the Kubernetes version. Now, something funny happened there when it got edited. I think it's because of the zoom, like I mentioned, on the terminal size. But this actually, I put 1.20.7, but you can see that the 7 appeared down here for some reason. And then we specify the service principal ID and the client secret and the load balancer SKU. I'm going to try. Yeah, I think we'll stick with it. We'll stick with this terminal size. I think it's maybe one smaller. Is that still readable?
Yes, sure, readable.
Okay, let's go. Let's go with that then, because then hopefully we'll get less problems with the wrapping. Now, in real life, when you do this, it will take maybe around 7 or 8 minutes. But the version of, because I'm running this through a recording tool, it will be a bit quicker. So we don't need to wait 5 minutes. We should just, it will take about 1 minute, 90 seconds, something like that, hopefully. So there is something I should point out here, which is at this point, you can see that we're not specifying that the cluster is an eBPF cluster. That's because at this point, we are not creating an eBPF cluster. We're creating a normal Calico Linux IP tables cluster. What we'll do is in a minute, we'll run a benchmark on it. And then when we finish benchmarking it, then we will convert the cluster to an eBPF cluster.
Oh, that's a, oh, sorry, I don't want to interrupt, but this is a good question. You can transform from normal version for a eBPF version. You can do this.
Yes.
Could you do this? Oh,
yeah. Not only can you do this, but any existing flows should not be disrupted when you do this. So if you have an existing TCP flow, it should remain using the old data plane until that flow terminates. And when that TCP flow terminates, then any new TCP flow will go onto the new data plane. However, even though that's possible, of course, we've all supported networks in production. Whether I would do that in production, maybe not. But yes, in theory, that's possible. So this is great because it means that we can give you the right data plane today. But if in 3 years' time, there's a new technology that is more suitable, you can switch to a new data plane. So while we finish talking about that, you can see that the command completed. So it's given us the JSON for our cluster. So we're running the cluster now. And like I said before, I've changed all of these IDs so that they are not private. And this is a public key, so we don't need to worry. So we're now running our new Kubernetes cluster. And this cluster is running Calico, but it's not running eBPF yet. So I back up my kube config. So I'm just copying my kube config to some other location so that I don't lose it. And now I can ask Azure for the credentials. So I ask Azure for the credentials for the cluster. I'm just realizing if I move my window up a tiny bit, then we can get rid of that tiny banner that's blocking you being able to see the bottom of the screen. There, that's better, isn't it? Okay, so if we look back at what we've done here, I think you probably missed this command, didn't you? So we copied my kube config away just to back it up. Then we asked Azure for the credentials for this cluster. And now we can use kubectl get nodes. And we can see our new nodes. And you can see they've both been up for a short amount of time on the version we requested. So now that we're at this point, we have a cluster running the Calico Linux IP tables data plane. So let's run a quick benchmark. So we're using this great tool called Kate's Bench Suite. And you can see that we just specify the client node and the server node, but you can see I made a typo. So we specify the client node and the server node, and it deploys a pod on the client and the server, and it checks the bandwidth and so on. So we'll just wait a moment for that to finish. When this finishes, we won't look at the benchmark results straight away. We'll just move straight on to the next part of the demo. And then when we finish the demo, we'll have two sets of benchmarks to compare. One set from the IP tables data plane and one set from the eBPF data plane.
Chris, just to help our audience, maybe someone don't know what is KNB. Could you just give a tip about this?
Yeah, this is a great tool. This is a really great tool. So you can find it if you search GitHub for Kate's Bench Suite, this phrase here. KNB is, I actually assume it stands for Kubernetes Network Benchmark. It must do. Kubernetes Network Benchmark. All you need to do is give it a client node and a source node, and it will deploy a pod on the server, and it will deploy a pod on the client, and then it will run iPerf. It will detect the CPU and so on, like so. You'll see it detects the CPU, detects the kernel, blah, blah, blah. And then it does the tests. And then it gives you a really cool bit of benchmarking like this, pod to pod, pod to service. Now you can see that because in this demo, we're running on servers that have gigabit NICs. That's why we're not seeing 10 gig or anything here. We're not running on big instances. Cool. So there we go. Right. So that's how we deploy. So just to wrap up where we are now, that was the process for deploying a Linux IP tables Calico Kubernetes cluster. So if we jump on and we move straight on, I'm going to show you the NAT part of it. Now, do you remember in that diagram I showed the audience that with kubeproxy, we lose the IP address of the external client? I just want to demonstrate that quickly before we move on. So I deploy this useful tool called YowBank, which is just a simulated microservices deployment. It's very simple. And you can see that we're running a pretend database, a pretend customer, and two pretend summary. So it's like a three-tier microservices thing. So we just wait until that's running properly.
Chris, if someone want to follow something similar that you did, there is some place, your GitHub or something, or tutorial that we can follow to try like
Yeah.
you?
Yes, absolutely. So specifically for the Azure case, there will be a blog post quite soon that will on the Project Calico blog, which will cover pretty much the same steps we're doing here. I'll just pause that for a second, hold on. And also on the blog post, you'll see there are lots of similar blogs which tell you how to do this on AWS, how to do this on other clouds. Yeah. Cool. So you can see that it's running now. So we create a load balancer. Kubectl will apply, and we just apply some load balancer config. And then we wait a moment for an external IP. And here we go. We've got an external IP. So now I can curl it. I think I remember I waited a bit of time because I know from experience that if you hit the load balancer really quickly, then it's very slow to respond, or it doesn't respond at all. So I think I just waited a short amount of time. Here we go. There we go. So we get this fake response from this fake bank website, but we don't really care about that. All we really care about is seeing what we get in the logs. So now we look at the logs for the customer node, the customer pod. And you can see, this is the important thing, right? Because we're not running the eBPF data plane yet, the Azure load balancer has done a source NAT. And the IP address that we're seeing here is an internal RFC 1918 NAT IP address. So this is bad if we want to audit, if we want to filter, if we want to do some analytics. Okay, so that's it. So we've shown the performance without eBPF, and we've shown the NAT. So now we can watch me do this one. So now we're going to convert this cluster to eBPF. This is where it gets interesting. So the first thing we do, I think this step will be going away very soon, or may have gone away already, but it's not doing any harm. But essentially what we're doing here is we're patching the installation resource, and we're telling it that we want each node to select which interface to use based on which interface can reach Google's public DNS. So I have a strong feeling this isn't necessary anymore, but actually it won't do any harm for this demo. So that's why I did that. Now the next thing's quite interesting because we're about to convert this cluster to use eBPF. Now, in order for the Calico component Felix on each node to talk to the Kubernetes API, it traditionally uses a service to do that. And that service is managed by kubeproxy. But of course, kubeproxy is going away. So we can't have Calico talking to the Kubernetes API via a kubeproxy service because kubeproxy won't be here anymore. So that's why we have to do this next change. This next change is to find out, first of all, we find out from kubectl, from a config map in kubesystem, we check what the true URL of the Kubernetes API is. And then we create some YAML. And what this YAML that we're about to apply is going to do is it will tell the Tigera operator, which is the tool that deploys Calico, that we want to talk directly to the Kubernetes API rather than to kubeproxy. I'm just wondering if something's gone wrong with the tool or if I paused it by accident. One sec. Never mind. So what we're going to have to do now, you get to see me do something live. I'm going to use this tool called Askinema Timing. I'm going to adjust the timing of the recording. I think something was wrong with the recording file, so I'm hoping that by... Okay, so this wasn't supposed to be part of my demo, but what I've done here is I've adjusted the timing of the recording so that it should play back quicker. Let's give it another go. So we're repeating those last steps that we saw before. There we go. Now it's working fine. Okay, good. So if you recall, I said that we wanted to get Calico to talk directly to the API. So we're applying a config map in the Tigera operator namespace, and it's telling the this config map is telling the Tigera operator that deploys Calico that it wants to see the endpoint here. And it's basically just saying, don't use the Kubernetes, the kubeproxy service, use the API directly. So we do that, then we wait 60 seconds because it takes a moment for the Tigera operator to notice the change. And then we delete the Tigera operator pod. And when it comes back, you can see that the Tigera operator pod restarted immediately. And when it did that, it picks up this new config. Now, I have a feeling as well that this has recently changed too. I have a feeling this that the pod restart may not be necessary anymore, but I did it because I know it works. So I think it may be that after we apply this YAML here, that there's no need for this restart. But it also does no harm, so it's fine. So once we've restarted that, we can see that we're still running kubeproxy, right? But we don't need it anymore. So we can patch the daemon set. We patch the daemon set, which is operating in the kube system namespace, and we say that the daemon set for kubeproxy, we tell kubeproxy that we don't want it to run unless the node is not Calico. But of course, all the nodes are Calico. So essentially, we're telling kubeproxy that it shouldn't run on any nodes. So you can see that kubeproxy is not running on any nodes now. And the last step is that we kubectl patch. We patch the Felix configuration. This is a custom resource. And we turn on BPF. Now, in a couple of weeks' time, I'll be doing a webinar about how we can do a deep dive into the eBPF packet flow. But today we're not doing that. So I just want to show you that eBPF's running. So I thought the easiest way to show you that eBPF is running now is if we look at the logs for one of the Calico nodes and we grep for BPF, then we get loads of BPF stuff. So
where you
yeah.
can find your ideas, the information about your workshop, your deep dive?
On the Tigera website, there is, if you go to the Tigera website, there's an events section. It will be published on there soon. But actually, I don't think it's published yet. I think the event is I believe it's mid-July, but it will be published quite soon. But we have loads of great free events on there. So yeah, I encourage you to go and take a look.
And there is in Tigera, there is a certification, right?
That's right. Actually, we have there are actually 2 certifications now. Yeah, we have the level 1 certified Calico operator, which is a really great course. Actually, I did that course myself before I joined Tigera, and I really enjoyed it. And we also have a new AWS certification, Calico AWS expert. So yeah, those are both useful. So that's it. So we've shown now that we've turned on eBPF. Now we can run the same benchmark that we ran before. To be honest, the only reason this is happening quicker is because I changed the speed of the recording. But the point is that these results, we will compare these results in a minute to the other results that we took. And then the last part that we want to show now is, before we look at the results, is if we look at this one. You can see this is quite funny, actually. I came back when I recorded this demo this morning. I came back to look at the logs before I hit the site again myself, and you can see 2 bad guys on the internet have been trying it already. You can see they're trying to log in. I don't know what this guy's doing, but this guy is definitely up to no good. So then you can see that if I run the curl again, I get the website again. But now if I look at the logs, you can see that you get my real public IP. Although actually I edited this public IP because I don't want to share my public IP. but the point is you get the public IP. So that's it. So just to recap, before we look at the benchmarks, just to recap, we showed how the performance is better, we showed how to convert one to the other, and we showed how you get the source IP preservation.
Great presentation and amazing information. Calico and eBPF are open source projects, right?
Correct.
How can we not know more about the projects, and it's possible contributed? What's the expertise we should have to contribute for the projects? We know that we have many different opportunities to contribute, like a documentation or maybe such kind of training, etc. But how you can contribute for the both projects?
So that's a really good question. So both, if you go to projectcalico.org, you will find that there's a link on there to the community website. And as with most open source projects, you can get involved at whatever level you're comfortable getting involved. If you just want to submit a docs PR and help us to improve our documentation, that would be amazing and appreciated. And all our We have some good open source documentation, but obviously we would love some contribution there. We have community meetings, and on our Slack channel, it's part of my role is to talk to users and understand where they're encountering challenges with our product, because no product is perfect, right? So even if you just want to contribute by coming to Slack and sharing your experience, that would be useful. And then if you have expertise, if you have deep technical expertise in networking and Go, or you want to contribute to eBPF, those are both, Calico and eBPF are both public open source projects. So yeah, it's all there. I thought we should look at, we can actually compare those benchmarks quickly before we run out of time, because we never actually did that. Let me just show it. So if we pull up the eBPF results, no, let's pull up the standard data plane.
That's the point. That is a good point. We can see a better performance from the network using the both. When you talk about a few implementation, very simple, few microservices, few low traffic, maybe you'll be comfortable with a default implementation. But when you go to a very large implementation with many microservices, much conversational, transactions, etc., you can feel a huge advantage to adopt this kind of chance, this kind of patch using Calico and eBPF. So, Chris, from your experience, where which are the biggest implementation, or how was the challenges, and the results was good enough to justify use this kind of the Calico and eBPF? Do you have any number from the current implementations?
I don't want to give you a number that isn't accurate, and I actually don't know. A particular cluster size, but I can find out that number. I think someone was going to share our Slack channel, and I will join the CNCF Slack channel for Cloud Native Live in a minute. So let me find out the answer to that one offline for you, because I don't want to give you the wrong answer, and I don't know. But what I can tell you is that one of the advantages you get when you, if we switch back to that slide again, one of the advantages you get when you replace kubectl is actually latency reduction. And you see this caveat here. It says most noticeable with many short-lived latency sensitive applications. So what's cool about this is that this latency reduction starts to be more and more impactful the bigger your cluster and the more short-lived connections you have. So although you get these immediate benefits from kubectl, from taking away kubectl, excuse me, if you have a cluster that has loads of short-lived sessions, you will see loads of benefit. So actually the benefit becomes even bigger with a larger cluster. I was going to show you these as well. So you can see that this is the standard data plane, and you can see that this is a gigabit NIC. So you can see that it's doing 900 meg TCP and 800 meg UDP. And you can see that the eBPF data plane, because I changed tabs up here, the eBPF data plane is doing 900 meg TCP, just the same. And you can see it's now doing nearly 900 meg UDP as well. So the improvement here doesn't look as big as the slide, but that's simply because this is a gigabit NIC and you don't see the improvement so much. I could probably have done a demo on a 40 gig bare metal, but I didn't want to pay for it, so here we are. And the other benefit you can see is in terms of CPU utilization. You can see that where is it? You can see that here it's 15%, here it's 18%, so it's similar. But you can see that for UDP, it's 60% client CPU for 800 meg. But with the new data plane,
amazing.
It's faster and it's using half as much CPU nearly.
Yeah, it's amazing, this number. Amazing.
And also the same here, 800 meg versus nearly 900 meg. And the same thing, 61% down to 32%.
Really amazing. Really amazing.
Yeah, it's good.
It's good. Oh, Chris, it's amazing. A very strategic presentation and demo. Many things to learn and improve. I hope you can participate in the next deep dive because it's really amazing. Thank you so much. We don't have more questions. We have a question, and I want to really thank you so much for this presentation today, this live today.
Yeah, no worries at all. That's fine. I'll go and join the Slack channel, your CNCF Slack channel, Cloud Native Live, and also people are welcome to join us in the Calico user Slack channel, or just look at my Twitter or anything else. Yeah. So thank you so much for taking the time.
Thank you, Chris. Thank you. Thanks, everyone, to join us today in the last episode of Cloud Native Live. It was great to have you, Chris, with us talking about Calico, this amazing project with eBPF. Really amazing numbers. Half use of CPU. It's really amazing. Thank you so much. With more performance, of course. We also really loved the interaction with. We don't have many questions, but I
just saw that question.
Well, I have one question here now. Where could you find more about performance statistics of different setups? Do you have others?
Probably the best place to look for that is the Project Calico blog. We are testing different scenarios and lots of different platforms, and we continue to publish performance stats for different clouds and platforms there. So that's the best place to watch. And not only that, even if there are some particular results that you can't see there right now, we're publishing new ones every so often. And also, if there's a particular thing you'd like to see, then come and tell us about it in Slack, and maybe we can prioritize that one.
Thank you, Chris. So, everyone, thank you so much for joining us today, and see you next weekend. Next week, not next weekend. Thank you so much, Chris. Nice to meet you. Thanks so much, everyone.
Take care.
Bye-bye. Take care.